So here I can say, I configure the minimum resources for this pool is 20 GB, yeah? Which is actually more than the fair share, because the fair share was originally 10. And so what Hadoop will try to do, it will first, before it serves anyone, it will try to fulfill that min resources, and then whatever you have left, that is then redistributed across the remaining pools.
Can you do it in percentage as well? Like
Yes, yeah. Well, if you so basically what I can do here, and we will see it later, I can say here 40 GB and 10 GB. Yeah, and then what it will do, you claim more than available, it will then percentage-wise redistribute it. Yeah. Okay. So this is what min resources allow you to do, and so you can guarantee at least a specific amount of resources to a specific pool, and this is in case if you need to fulfill a certain SLA or something. Okay. Even though I have min resources specified to this pool, if I don't submit anything in that pool, then those resources are redistributed across other active pools.
it's a risk, right?
Patience, patience. All your answers, all your questions will be answered. Because if I would not do that, then I would allocate 20 GB. But if for a whole day production doesn't run anything, then those resources are there sitting idle, and I'm not fully utilizing my cluster. Yeah. So this is the reason why, since there's nothing in production, we might as well reassign those resources to other stuff that is running. Yeah. Okay? So far so good, right? No questions, please. Now, and we will come to that. So what happens if I then now, what happens now if I then suddenly submit here? We will come to that. Okay. Now, and this was the percentage-wise bit. So basically what I can do, what happens here is, now I only have 30 GB. Yep. I specify here min resources 50 GB, because that's, I want some guarantee. But research pool now is also configured, but they say, well, we need minimum 25 GB. So what happens then is these two are first fulfilled. This is the first that Hadoop tries to fulfill. But since 75 is more than it's available, it will proportionally distribute those resources according them. So in this, according to the min resources. So here we have twice as much as here as min resources, so we will distribute them accordingly. So here we will assign 20 GB, 10 GB, and this is then twice as much that's there. And so all 30 GB is used up, and sorry for Bob, but at this moment in time we have nothing for him.
But it didn't have the min resource also defined.
Sorry?
Because it didn't define the min resource.
Yes, because he doesn't have any min resources,
But
and so
if he had min resources, then all
then
three would
yeah.
have proportion.
Yeah. Okay. Are we good so far? All right. Some other stuff. If we have min resources which is below the fair share, then nothing changes. Then everything is just equally distributed across, because in the fair share is more than the min resources. So from then on, once the min resources are fulfilled, then Hadoop still tries to maintain a fair share across all the pools. Okay. So, and here we come to the weight thing. So now what happens in this case, everybody has the same weight and is considered equal, right? In the fair scheduler, you can also add a weight to a specific pool. So what happens is that a pool with a higher weight, yeah, will get more resources assigned during the allocations of the resources to the different pools. Yeah. So in case if you look at the glass of waters, then if you add a weight of 2, then you get twice as wide a glass or a pool. Yeah. And then I have a wider pool, but it still tries to maintain a fair share across my different pools and the fair share in terms of height. Yeah. Okay. So that means that when I reallocate resources, yeah, then the allocation would be 2, 1, 1. Yeah. So if I have 4 gigabytes spare memory, then he will get 2 gigabytes, he will get 1, and he will get 1. So in that way, it will then redistribute. Yeah? Obviously, also, min resources still apply. Okay? All right. So that is the single resource fairness. Yeah?
Sorry, in the previous slide, there at the last, for Bob, min resource is not given, but only the weight is given. Is it something like weight, rules?
No, min resources has priority over weight. Yeah?
Okay,
So
that's
min
fine.
resources needs to be first fulfilled. Yeah. So if I had set min resources 30 here,
Okay.
yeah, then this pool
Got
will
it.
be full and both will be empty.
Got it.
Yeah.
So min resource is first.
Min resources has higher priority.
Priority.
Yeah. Okay. All right. That is single resource fairness. Yeah. So we allocate the resources across our pools based on memory only. Now we have dominant resource fairness. That means you take into account both memory and the cores as well. And what happens is you will allocate the resources, the requested resource, based on the dominant resource. So what does that mean? Yeah? So dominant resource fairness. So this is an example. So we have Alice, which is here. Alice is assigned 6 GB and 3 cores running. So that typically would mean maybe 3 mappers, 2 GB each. Yeah. Bob currently has 4 GB, 2 cores, yeah, running. Okay. So when a next resource is requested, a next container is requested, who will receive the next container? In this case, it will be Bob. Yeah. Why Bob? Because Bob has less than Alice. Yeah. In both memory and cores. So the next container will be assigned to Bob.